Welcome to the On-Premise IT Roundtable, the only podcast that dares to be both on topic and on location. My name is Tom Hollingsworth, and I am a part of Gestalt IT, and each time we meet, we bring together luminaries from the IT practitioner industry to speak about a topic, or a premise, if you will, that is important to them and to the community at large. This episode is brought to you by BlueCat Networks, and I'd like to take a few moments for each of our guests to bring their information and their knowledge to the panel by introducing themselves before we jump into the premise. Starting with Arthur.
Hello, my name is Arthur Baig, and I live my life as an enterprise solutions architect with a specific focus on public and private cloud infrastructure. You can find me on my blog, arthurbaig.com, and my Twitter handle is also Arthur Baig.
Hi, my name is Larry Smith. I am actually a technical solutions architect focusing on automation day to day, working with a lot of network engineers and folks also in public cloud and private cloud. And you can find me on Twitter at Mr. Ellie Smith Jr. And occasionally I'll blog at everythingshouldbevirtual.com.
Andrew Workdan. I'm the Chief Strategy Officer at BlueCat. And BlueCat here, we're focused on DNS, DHCP, and IP address management. And I spend my day thinking about our product strategy and working with our strategic customers and prospects and really trying to figure out how we can add more value. That's sort of my passion in life. I can be found on Twitter at @Workdan, and I also host a podcast called Network Disrupted that you can find anywhere you find podcasts.
All right. Well, thank you all for joining us today. Should be a really good episode, so let's jump right into the premise. Now, I don't need to tell everyone out there listening that cloud is kind of important. I think we kind of fought that battle and won. Cloud is the way that we consume our infrastructure. It is the way we consume our software. I think it's even the way we consume our entertainment, if my kids are to be believed. However, cloud doesn't always work the way we want it to. And that has led to the rise of probably one of the craziest memes that I've seen, that it's always DNS. Whatever your problem is, no matter what the troubleshooting happens, if you don't think it's DNS, it's always DNS. But the fact of the matter is that a service like DNS that has become so ingrained into what we do belies the fact that it is super important to the way that our modern cloud architectures work. So the premise of this episode is that DNS is critical for modern cloud. Now, when we were going through the pre-event discussion here, we were discussing some of the aspects of it. And I thought it was funny that we were going on. And as soon as someone would bring up a topic, we'd be like, oh, and this other thing. But I want to go ahead and I actually want to start off with Arthur. One of the things that you have talked about a lot is this, the way that modern cloud architecture works. And you have a unique perspective with the things that you do in your daily life. So how critical is DNS to the operation of modern cloud?
Well, for me, DNS has always been, and still obviously is, the key to a reliable and scalable cloud infrastructure. And that, I guess, is the key thing to remember, because, I mean, sure, it started with, we all know, simple name resolution. But at the turn of the century, even back in late 90s and early 2000s, we started seeing service discovery in a way of Active Directory when it introduced service records, right? So it was more than just name resolution. And in the day of today, for example, with all the cloud native services, microservice architecture, and all those kind of things, and in order to provide reliable and scalable name resolution to the services that you are providing, DNS is key to it. I mean, there is a reason why, like you mentioned, that it's always DNS. There is a very popular DNS haiku as well. And the reason is because it is so important to infrastructure that you cannot imagine a scalable infrastructure in the way it has to scale these days on demand, while the networks are created and destroyed at will. DNS is the only thing that keeps it all together. So I think it's the key service without which you can't build a cloud infrastructure reliably.
So how does DNS help reliability? How does it allow us to build architectures that are more resilient from failure. And the reason I ask that is because I'm coming from a networking background. So I'm going to play the part of the poor networking engineer here. And when someone says reliability, I think of things like, oh, HSRP or GLBP, where I just set up a couple of routers and they share an IP address or they have a MAC address. And I don't care about DNS, but is that the way that modern cloud works? Does DNS kind of a something that reliability is kind of built into?
So yes, I mean, let's take a very simple example these days, for example. So the first thing that started happening on the cloud infrastructure was auto-scale networks or auto-scale deployment, where you got more instances added to your application, for example, which was serving web traffic to your customers. And that follows, for example, the load on the service. So if it was that old kind of infrastructure where you assigned static IP addresses to your instances serving those web traffic, it would have been impossible to scale at will. But just because of the DNS or the flexibility that DNS brings, as soon as the instance is added, all is fronted by a load balancer, your traffic goes to that. And in the background, DNS is handling all the traffic, routing traffic to different instances and making that infrastructure reliable, because you can then keep adding instances automatically and scale with the incoming traffic. Same with API gateways, for example, or your microservices. When they are fronted by a load balancer, the DNS is the thing that actually keeps it all very flexible. So that's how reliability is achieved in all these cloud-based or cloud-native infrastructure and microservices using DNS, of course.
So Arthur, I hear you say a thing, and Tom, you made a comment about, being the traditional network guy or whatever, right? Right. We all love our spreadsheets. Well, I say we, some love their spreadsheets. So are you saying that we don't necessarily need to keep those and we can rely on such infrastructure as DNS or whatever to facilitate those or facilitate the need for a spreadsheet, kind of a CMDB perspective? Be able to leverage that for be able to building on top of discovery, being able to understand what our environment might look like, what is contained within it, and things like that. And also, again, not caring about IPs to make Tom happy. He doesn't have to remember all of those 6 IPs anymore. Is that what you're saying out there?
That's exactly what I'm saying. And I mean, I think we all know that traditionally network admins, like you both, actually wanted everything to be statically defined, segmented, nicely segregated, so you know exactly what's going on. You could even tell, from the IP address which service this particular instance might be running, and that's all well and good, and that worked very well when the time it did. But I think now there is a realization that software-defined networking, in this sense, when it scales, provides the benefits that this static environment couldn't before. And to be honest, I think network admins these days are quite open to this kind of change. And they are actually becoming more accepting of this DNS, the new way of doing things. And this is exactly why I preach to my customers, saying that, as soon as you start on a project that involves either refactoring or, for example, those kind of cloud native services or whatever you're trying to do on the cloud infrastructure, bring in the network team right from the start, get them involved into your processes. And so that, because they are the masters of, creating a scalable infrastructure and removing bottlenecks from your network. And also at the same time, planning ahead so that you still have the capacity going forward. You don't have to redesign the network. So getting them into the conversation right from the start allows your network to become more future-proof. And as long as they know exactly how it's been designed, they'll work with you to make it that way.
Now, I want to give Andrew a chance to jump in here, because you guys have both touched on the idea that there are some very old-fashioned ways about keeping track of all this information. I mean, I can remember having a static list of IP addresses that I managed. And then, certain subnets got DHCP, and, DNS made a whole other kind of issue come up. And I can, as an MCSE on Windows 2000, I can remember having to learn the intricacies of reverse DNS lookups. and the horror that I had to deal with there. But I mean, I'm sure that there's a better way to keep track of all this, especially if you're going to start leveraging DNS for things like service discovery. Now, Andrew, BlueCat has done a lot of work in the DDI space, that being DNS, DHCP, and IPAM. So maybe, what's your perspective on this as you see DNS becoming more and more critical and being leveraged for a lot more things than simply, resolving gestaltit.com?
Yeah, and look, the cloud is just a major accelerant to that, right? Like, I mean, it's always been critical from a core design of reliable system standpoint. Create an abstraction layer for anything that might be hard coded there, so that you can change it rapidly. And the more things that are hard coded, the more fixed the infrastructure is. You're not building reliable infrastructure, and so DNS has always been critical as part of that. And the second quick point here is, we're all talking about it from the network perspective, and that is the perspective that half the world looks at DNS, and the other half of the world, especially now, and that's part of what we're talking about today, looks at it from the application perspective. DNS has always sat in the middle of the network and the application, and so we sit in the middle and listen to the conversations and speak to people on both sides with a different necessary set of requirements, and they both want to own it. There's a bit of like a tug of war going on now around DNS because of that. But for sure, in these highly dynamic environments, both the process of understanding what's there through any sort of discovery with ephemeral compute, things that can change faster, as well as this ability to abstract appropriately and scale is a critical part of modern applications, and you can't do it manually anymore. It used to be in our business, you'd look at a company would get to a certain number of IP addresses or DNS records, and that meant that they needed a DDI system to manage it. Great. That has changed dramatically over the last few years, and now it's not about the number, it's about the amount of change. If I'm going to automate something, if I'm going to drive massive changes to it, and it still needs to be reliable, then those changes can't be done manually anymore. And believe me, there are Fortune 500 companies that are still running their broad IP space allocation and reconciliation on spreadsheets. That's how it's being done, and that you just can't automate against that. So I think we're over that point of this being looked at as a annoying abstraction layer that needs to exist between the network and applications, to an enabler so that the network team can do their job appropriately too, and make sure that they're supporting the needs of the application teams.
So Andrew, I heard you say a couple of things about, again, kind of hitting out the whole point here of traditional networking. I think you hit on another point, is it is about the application, right? From a network admin perspective, what we're talking about now, are we seeing that maybe there's a shift from a network engineering perspective, or maybe I do need to manage DNS now, or do I need to manage these services at a little higher abstraction to be an effective network engineer, or do I not care? Because I mean, a lot of what we talked about, I mean, you could translate it as it feels more on-prem versus cloud, because we haven't really hit on that type of stuff yet. So I'm curious, we don't have to go there today. But what, does that make sense? Where I'm going with that is, we talk about all this shift of all these different roles over time. Is that shift happening from a network admin? Again, reiterating my point.
Yeah.
Do I now need to manage DNS?
So if I look broadly in our customer base, the DNS, and we sell DNS, DHCP, and IPAM. DHCP, IPAM has always had a home in the world of networking, because they're broadly care about, their job is to make sure that the IP space is being allocated appropriately, that it's not being reused. They don't want network overlap, that it's contiguous, that it lines up with routing strategies, yada, yada, yada. That's theirs. DHCP, same thing, very focused on network. On the DNS side, oftentimes that was being managed by the Windows Server team or some other team, or there's this carved out like critical infrastructure team. And so part of the benefits of what we sold is here's how to manage this stuff. It's better together type thing. But I think your point is right. I think there's also there's the application focus, and then there's also the rapid change to the network in general, as companies are investing in things like SD-WAN and changing egress patterns, and on and on and on, where if this stuff isn't done in concert, it leads to issues. And the amount, imagine a multi-billion-dollar company implementing direct internet access, such that there's direct egress to the internet from every local site, yet DNS is still going back through the data center, looking up the address relevant to where the data center is, and all the traffic going to the wrong place and not meeting their performance requirements. Is a very basic example of something that happens over and over and over again because there's no appreciation for why something goes to that IP address. It's not magic, it's just DNS.
I think this is where the evolution of DNS actually comes into play, where it started with, DNS was all very local, right? There wasn't a global concept. Well, there was, but, it wasn't that widely used. And now organizations are deployed in basically all the different kinds of geographic locations and hence geographic geolocation DNS services. But I think one of the things that was missing earlier on was the fact that every DNS was managed separately. And I think that created that silos, that, basically the crack where some of the information somehow fell through. So I don't think that what's required is management or the networking people knowing DNS and having to manage it. But they should have a view of it, because I think it basically then serves the same purpose as the spreadsheet or the segments did before. So as long as they know where everything is and where everything should be going, and if that's not be the case, then they can detect it. Then if there is one tool that actually covers private, public, all the different subnets or all the different clouds in one view, which is clear and easy to see, then I think that serves their purpose. So as long as they have access to that dashboard, if you like, they'll be happy.
Yeah, and then on top of that's just comes down to organization. But in the world of siloed based DNS of the past, where you had different people around the organization managing local DNS and on whatever, it doesn't really matter. That's where you just run into issues of you can't change the stuff fast enough, and you run into just tons of what I call DNS band-aids, and literally, authoritative data being copied, like point in time from one server to another with no interaction, with crazy forwarding rules. We've seen thousands and thousands of forwarding rules in the same company where so you get these almost impossible DNS outages, or not really an outage, the service is up, but people over there and randomly over there can't look up these records. Why? And, it ends up being just something ridiculously esoteric, and some dude, over there didn't do what he was supposed to do, and you can't, that's fine for a laugh and a beer if you delayed some project an hour or two, but if you're driving out cloud compute, you're driving out rapid change, that's killer. It can't happen that way. And so, yeah, there needs to be a broad understanding there of it's so ingrained with the health of applications, with the performance of applications, with the availability of applications, that anybody that has responsibility to ensure any of those things, or even the security of applications, should be aware. Otherwise it's either a tool in the toolbox they're not using, or a potential part of the architecture that they're not assessing as they figure out how they're going to deploy and meet the broader requirements. And so it's as you said at the beginning, it's always been critical, but it was treated as critical in terms of reliable. And when you build reliable systems, you usually don't build them to change, right? Excuse me. Like something doesn't change, it can be easily made more reliable. Well, now you have something that's changing massively. How am I to make it reliable? And it takes a bit of a different approach. I keep seeing your Adrian Newey awesome book behind you, How to Build a Car. And I think Adrian would have a few things to say about building reliable systems that have to perform under different situations. Yes,
my son's idol, Adrian Newey. By the way, the one next to it is another legendary McLaren driver designer. And the book is about them, the perfect car.
Yeah.
A bit of a segue, I know.
Yeah, that's good. I knew he wasn't talking about me with the book. So real quick, I was gonna call something out again. Is, you know, we've heard this theme we've heard it forever, and we're hearing it a lot on this conversation again, is this cohesive kumbaya between networking and applications and all these things, right? At the end of the day, we always say this, and we know this, it's all about the application. But, you know, we've seen it over the years where, let's be frank, let's be real. Network engineers like to keep things to their heart. If the port is up and traffic is flowing, they don't care unless it's broke. Generally, let's say generally, there are a few. But what I'm hearing from this theme is we have to, from a collaboration perspective, as you get these intertwinings of these DNS infrastructure service discovery and things like that, it goes both ways, but networking folks really need to care about the application at the end of the day, in my opinion, just to put it out that way, and vice versa, rather than, so they're not creating one thing and saying it works for us, we don't care about anybody else. And I see Tom is just dying to jump in, so I'm going to go on mute because I want to hear what Tom has to say.
Well, I think you hit on a very important point, Larry, and it's something that I've kind of picked up on recently, is that networking people have always thought about their environment in a very atomic unit. It's a router, it's a switch, it's a network segment. And that's just how we think about things. The segment from my desktop to the data center, from the data center to the internet, from the internet to wherever it needs to go after that. And likewise, systems people have always thought about their things in other atomic units, whether it's a server or a cluster or, you know, servers plus attached storage plus other things. But in this entire discussion, what we've been coming up with is the new atomic unit of the way that we think about things is the application, because it's not just a network segment. It's not just a server. It's more than that. It's a collection of servers. I mean, when we say 3-tier application, everybody listening to the podcast knows exactly what has to go into that. It's at least 3 servers. And so we no longer deploy things on a server by server basis. Like if I were to go to, let's just say AWS and create a pre-built image for, like, I don't know, like a lamp stack. When I click go, it will set up everything that I need to put that out there. But that could be 2 servers. That could be 6 servers. That could be 60 servers, depending on how big I want my application to scale and how many resources that it needs. And so I think that as we start looking at these types of operations, what we use as the measure of communication and reliability changes. When it's a network segment, it's an IP address or MAC address, depending on how far down you want to go. When it's a server, it's still an IP address or some other form of communication with that. But when the application gets involved, when reliability and resilience is important, now we need something a little bit more reliable than an IP address that could potentially change. I mean, that's actually one of the reasons why vMotion was both a godsend to the virtualization teams, but also a huge problem, is because we couldn't change IP addresses on the applications in midstream. So everything had to live one layer 2 adjacency away from each other. And if anybody's ever tried to build a stretched layer 2 data center interconnect across a country, you know how big of a pain in the neck that could be. We don't have that problem in cloud because we're relying more on DNS to fix that reliability issue than we are, oh, what if we just randomly change the MAC address in midstream? But as DNS becomes a more critical aspect of that infrastructure, you have to have ways to manage it that are not just scribbling things down on a napkin or opening up an Excel spreadsheet and getting lost. Or, you know, if you're really advanced, a shared Excel spreadsheet on Office 365 that everybody has access to, but they can all edit it at once. So what happens if you pick a DNS name or an IP address that somebody else jumps on top of too?
Yeah, exactly. I mean, that's basically the crux of the matter, that in the cloud infrastructure, because of the different components, and there's this concept of decoupling as well. So you build your networking services that they can work independently if you like, and you pick up their workload and run with it. At such an environment, and when you also need it to scale, for example, abruptly and without notice, the DNS names might not look pretty, but at least they work. And that basically is the whole concept why it's so critical to actually have that kind of a DNS infrastructure and writing your applications. And it's not just about today, for example, going forward as well, because we all know the pains that organizations are currently going through when trying to refactor their applications because of those embedded IP addresses in them. It would have been far simpler had there been a DNS address somewhere. So those kind of things. I think in the future, I think companies are now becoming more and more aware of the fact that they need to write their applications that way now, starting now, going forward, their life is simpler. But also, if they want their applications to be cloud native and have less pain migrating to a cloud infrastructure, DNS and sorting that out is key to their network success, let's say, or application success.
Yeah, sometimes a couple points. One is I've seen cases back to vMotion where a DNS server has been vMotioned to a different network and a different IP address, and that can cause some negative side effects. And given that IP address is going to be hard coded, which brings up Anycast, which is where the DNS team and the network team traditionally clashed in the past. Now it might have moved on, but for sure you should be using Anycast for DNS. Anyway, regardless, as interesting thing comes out as companies re-architect that same application, though, let's say it was hard-coded, some 3-tier whatever application, and they weren't using DNS before, and it was a very chatty application. And, so you see sometimes these very naive okay, well, we'll just update the code, so now it's using a DNS name. But it creates, 250,000 connections a day, an hour, however, and they've architected such it's going to always do a DNS lookup every single time, and that DNS lookup is going to add 20 to 30 milliseconds per call, and all of a sudden they've actually slowed down the application and they back right back out. So those out there re-architecting, there's the right way to do it and the wrong way to do it, but regardless of that, DNS is super good at creating low latency, rapid answers around the organization if it's been architected to do so and people aren't abusing it. It's actually, it blows me away how well this technology has scaled over the last 30 years, from its beginnings to where it is now, in terms of the size and the breadth and this massive global trusted directory that's highly distributed across, hundreds, millions of organizations, of owners. But internally, there's a whole nother DNS, the private DNS. And when we look at what's happening out there with cloud development, you see, like, our customers historically wanted to centralize DNS into BlueCat. That way there was a single control plane and a single API and a single mechanism for anybody to change it. As you start pushing stuff into cloud, you start seeing these overlay DNS solutions that are working with the organization, with the application, which might be the cloud service provider's DNS, it might be in Kubernetes clusters, wherever it might be. And so you're seeing a fracturing again of DNS, and that's not going to go away. It will fracture a bit, and so now it also comes down to best practices, how to do it that way. Zones should be delegated. And what we see though is companies that used to be very restricted on who can, for instance, create a authoritative DNS service to overcorrecting to the Wild West, creating all the problems we used to have, 10 years ago, but magnified. So we're sort of going through this another, with this becoming more critical again, it's also being decentralized, and that's creating operational issues, security issues, potential downtime. And so, at least from a BlueCat standpoint, like, we're working very hard to understand where we can add value there, because as it's become more critical, it's also become less reliable given the nature of the changes that are going on right now.
So, Andrew, I want to say one last thing real quick. Is you hit on something that is worthwhile of another conversation in the future, is kind of those best practices and how you integrate all those different spider webs of DNS solutions. You talked about Kubernetes, you talked about all the cloud providers. You could have your on-prem, you've got BlueCat, you've got all these different solutions. How does, getting into a conversation down the road of how does that look? What does it look like from a best practices perspective to make sure that, like you're dealing with your customers and folks like Arthur and myself as we work with customers and things like that to ensure, hey, we're not just bringing a bunch of mess and throwing a bunch of stuff at them and saying, have a good day. We're actually providing real valuable solutions for these integrations, but not only for today, but down the road. So I would love to have some further conversation on that at some point.
No, for sure. And look, part of it from a BlueCat standpoint is standing back from this notion that we need to be the only DNS solution inside of a customer, which is at first, like, frankly and transparently, conversations with the rest of the executive team, people are like, whoa, but actually we have an opportunity to provide more value than ever. And if I think any company in networking, if their goal is to remain the only provider at their customers for A, B, or C, they'll end up not being a provider at their customer for A, B, or C. It's just the way networking is going right now, which is good because it drives innovation. Change drives innovation.
Yeah, I think that's actually a good point for us to wrap this discussion up, Andrew, is that, you have to look at the way that you're consuming your resources, and you have to understand how you're doing things. And if the answer to your question is, well, this is just the way we've always done things, you're not ready for cloud.
Right.
Because even the people who are good at cloud understand that you're constantly changing. You're always refactoring. You're always trying to support new functionality and new technology that's come out. You have to be unafraid to break things. But in doing so, you have to have reliable things that you can look at to say, okay, I can trust this to give me what I need. You have to have a reliable infrastructure that people can trust to not break while you're playing with other things. And so ultimately, you need to use the tools that you've been given, like DNS and several other technologies, many of which are managed by BlueCat Networks. And we will hopefully be able to build something that will last a little bit longer than your average router or server, or hopefully, your average application. That will just about do it for this episode of the podcast. I want to thank everybody for joining us. If you have any questions for BlueCat Networks, I'm sure that they have a lot of great resources on their website that they'd love to share. Andrew, where's the best place to go to learn more?
www.bluecatnetworks.com.
All right. So for all of our guests, I want to thank you very much for joining us. And thank you to BlueCat Networks for bringing this episode to you. You can always find the latest episode of the On-Premise IT Roundtable on our website at gestaltit.com/podcast. And you can go to our YouTube channel at youtube.com/gestaltitvideo. Check out more episodes of the podcast, along with several other things that we do. But for myself, for Tom Hollingsworth, our great guests, and our friends at BlueCat, I want to thank you very much for joining us today. And we look forward to talking to you soon in the next episode.